Here we have note 5 for graphing systems of linear equations. In the first example, we look at the standard form equation. We want to pull out a slope. The slope will be 3 over 2, and we make it positive because of the negative in there. So it's a over b, opposite sign, 3 over 2. To find a nice point, we can put 0 in for x. As we put 0 in for x, we solve what remains. It looks like this will go through 0, 4. And so we want to graph this line. We go to our graph. The starting point's at 0, 4, so it's up 1, 2, 3, 4. And then we have to follow our slope. Our slope is telling us from the starting point we should go up 3 units, right 2. Up 3 units, right 2. We can go in reverse, which would be down 3, left 2. Down 3, left 2, down 3, left 2. Once we have enough points on here, we just connect the dots and get a quick sketch of our line. I move to the second equation. As I move to the second equation, we notice that it's in the slope-intercept form. I look at the slope. The slope is 3 halves. Immediately that's telling me that there's 2 possible outcomes for this. My slope is 3 halves for the first line. My slope is 3 halves for the second line. So that means that the lines are either going to be parallel or one line will lie on top of the other. As I look at this starting point, it gives me the same value. Since it gives me the same value, plug 0 in for x, leaves me with 4. That's the y-intercept. It tells me that when I graph this, it's going to be the exact same line. And so as this creates one line on top of the other, it tells me my solution would be that the lines coincide. Coincide means that there's an infinite number of solutions. With infinite solutions, that means I have just tons of answers, but it's not all reals. For it to be all reals, I'd have to shade everything in, and nothing's been shaded in. It's just all these points that are represented by the line, so we say there's infinite solutions. That's example number 5.